In this segment, we'll talk about what kind of prior knowledge you will need for learning about interpolation. So what is interpolation? So interpolation is basically that you have n plus 1 data points given to you, and these are the n plus 1 data points. And what you want to do is you want to be able to make a function f of x go through all of these n plus 1 points. In your other classes, you might have looked at some like in your statistics or thermodynamics class, that you are given y versus x, like specific heat versus temperature, let's suppose, and you want to find out what the intermediate value is. So you're given the value of x and y here, x and y here. So you generally approximate by a straight line, found the value of y at some other value of x which is given to you, and that's what we call interpolation. So that's straight line interpolation. You are given 2 points. Now, keep in mind that interpolation can be done to any function. It does not have to be a polynomial. It does not have to be a straight line. So, for example, you have here this is a straight line a naught plus a1x, which is the first order polynomial. You could have the function f of x to be equal to a naught plus a1 e to the power x, where it is being interpolated to an exponential function. You could have it to sinusoidal functions and so on and so forth. And the only reason why we use polynomials most of the time is because they're easy to evaluate, easy to differentiate, and easy to integrate. So let's look at this example here where specific heat of air is given at a constant volume, and these are the temperature values, these are the specific heat values, and you're asked to find out what the value of the specific heat is at 960 K. So the first thing which you have to do is to choose, you would have chosen the two closest points, which are these two in this case, and these will be the corresponding specific heat value temperatures. And what you would have done is that you will assume that, hey, it's a straight line between these 2 points, and then found out what the corresponding specific heat is. So if that is the case, then we know that, hey, that we are going to draw these 2 points here, and this is specific heat at constant volume, this is temperature, and you're going to draw a straight line. This is 900, this is 1000, and you want to find out what happens at 960. So that's what's going to give us the corresponding specific heat right there. So you might have seen that when you took your previous classes, and when you had to find the temperature, the value of y at a certain value of x, then what you did was you said, okay, if this is x1 comma y1 and this is x2 comma y2, then if I want to find the value of y at a particular value of x, then y is given by this formula, y2 minus y1 divided by x2 minus x1 times x minus x1 plus y1. So you can very well see that if I had to look at this, this will be x1, this will be x2, this will be y1, and this will be y2. So I could very well use that. So the specific heat at 960 will be equal to, so these are the two y values divided by the difference between the corresponding x values times 960 minus x1, which is 900, plus y1, which is 1.344, and this number here turns out to be 1.3392 kilojoules per kilogram Kelvin is the answer. So that's the interpolated number which you want to see. So what we are going to see in our in this particular chapter for interpolation would be, hey, why do we only interpolate to a straight line? Could we have interpolated to a quadratic polynomial, to a cubic polynomial? And why do we want to even do that? So that's what's going to be the extension to what you already learned about interpolation from your previous classes. And that's the end of this segment.